Hello, everyone. In this lesson, we wish to cover how to solve inequalities. Okay, these questions are all selected from calculus text, and these questions are questions from calculus text after I have taken derivatives of them, first order derivative. Okay, so this lesson is made for my pre-calc class students and my calculus class students. And so for those of you who are in pre-calc class, you're just solving inequalities. And for students who are in the calculus class, you need to understand you're not actually seeing these questions directly in the calculus text. Is I take those questions from calculus text and I take a first order derivative. So all of these questions on the left-hand side, they are the result after taken derivatives, okay? So of course, for calculus class student, you know the reason why. And it's because we try to identify the interval of increase and the interval of decrease, okay? So without further ado, let's select a couple questions. I'm trying to control this lesson around 1 hour. And if necessary, I'll make another one. So let's start from the first one, which is the simple one. Okay, so first one, we got 6x squared minus 30x plus 24, and we wish it to be positive. Okay, solving inequality, we need to understand these statements, all of these are actually if statement. What do we mean by if statement? If statement meaning that, for example, in this case, right? It says if, when you're asked to solve inequality like this, it means, okay, usually we say save for x. Okay, so for all of your algebra classes and these kind of wording it has the following meaning. It says, if this is true, okay, if this expression is greater than 0 is true, solving for x meaning is to find all possible solutions, which is to identify all possible input, such that the output is positive. That's from the function perspective, right? So another interpretation is that suppose, right, we have a function called g. Okay, so this is to explain the meaning, right? The meaning. So suppose we have a g function, okay, and g function is equals to this given left-hand side. Okay, we're given the left-hand side, so we're assuming to be a function. So this whole thing, that solve for x for this, that means that the x is the input and g is the function. That's the rule. It produces output. So in this case, is that we want the output to be positive. Okay, so this is wanted. And we want to find out, okay, so we want to find out what are the possible values, what are all the possible values, okay? We want all possible values of input. Input x such that the output is positive. So given output, we're looking for input, okay? So for all of these questions we have here, it's the same meaning. Okay, so without further ado, let's move forward with number one. Okay, and of course, when you see this question, your first instinct is to factor out the 6. And indeed, we can factor out the 6. So 6 is factored out, right? And we basically divide 30 by 6, right? That's 5. Divide 24 by 6, that's 4. And we want it to be positive, right? So 6 times something positive, and 6 is a positive number, right? If we divide both sides, by 6, we can get rid of the 6. Do we have to get rid of the 6? No, we don't have to, but it would make it easier. It would make it easier. Oh, by the way, there's another principle we must observe when solving inequalities. Okay, so before we continue with number one, we'll come back to number one. For all the 6 mathematical principles, we have if, right, A is the same as B, then A times C is equals to B times C, provided that C is not 0. Okay, so that's the principle we have in our 6 mathematical principles. Okay, so if, then. All right, however, for inequality, suppose that we have if, right, A is larger than B. Equal is changed to larger. And we say, can we just directly change this equal to larger? The answer is no, no, no. Okay, it's a resounding no. Okay, so this piece you cannot use. Okay, so let me cross it out just to show you. We're going to cross it out. Okay, let me find my symbols to cross it out. Okay, that's wrong, 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 completely wrong. Okay, so what would be right? What would be right? Okay, so here's the right principle. The right principle says if A is larger than B, then, okay, then A times C is larger than B times C, provided that C is positive. Provided C is positive. C must be positive, okay? And if A is larger than B, there's another statement, okay? Then what if C is negative, right? Then you'll be thinking, then A times C will be less than B times C if C is negative, okay? So that statement, okay, so let me clean this up. This statement is wrong, okay? So this is wrong. And the following two are right. The following two are right. Okay, so these two will be right. And in any case, C cannot be 0. Okay, remember, in mathematical principle number 4, we cannot divide by 0. We cannot multiply both sides by 0. In the inequality case, we cannot divide by 0. We cannot multiply by 0 either. Okay, so that's the mathematical principle aspect. Okay, that's a mathematical principle aspect. I hope you guys understand. Then some of you may be asking me why, right? Why we multiply? We can understand that if we multiply both sides by positive, then sure, it's going to stay, both sides. A is greater than B. Then if C is positive, then A times C is greater than B times C. But if we multiply by negative, why that is going to change? So I have a simple explanation here. This is the reason why. Okay. Suppose you have a number line. Okay. Suppose you have a number line. On this number line, so here we got a 0 right in the middle. Okay. Suppose we have 3 on the number line, right? 2 is less than 3. 2 is less than 3, right? We know for sure. 2 is less than 3. However, if you multiply 2 by negative 2, so negative 2 here, and you multiply 3 with negative 1, negative 3, then you will have, right? So 2 multiplied by, so this way you have negative 3 less than negative 2. If that makes sense, right? So 2 is less than 3, but negative 2 is larger than negative 3. That's why we have the switch. Okay, so you can write this in another way. Let me write negative 2 here, negative 3 here, right? So you will have to switch the directions of the inequality sign like this. Does that make sense? Okay, I hope that makes sense. That's a simple example to support this principle. And of course, that's always true. That's always true. You don't need to question that. Okay. All right. So now we can proceed. So you can see solving equation and solving inequalities are two different games. They are completely two different games. And the other principle we are about to use is mathematical principle number 6. Okay, so we're going to delay the number 1 for just a little while. Okay, in just a few minutes. Okay, mathematical principle number 6. Okay, number 6. You should have your index card, but let me just remind you. Okay, a positive number multiply a positive number is positive, right? A positive number times a negative number is going to be negative. All right. And then a positive number, a negative number times a negative number is going to be positive. And a negative number, okay, a negative number times a positive number will also be negative. Okay. All right. And for dividing, a positive number divided by a positive number is a positive, greater than 0. Okay. And a negative number divided by a negative number is positive. However, if we have a positive number divided by a negative number, then the quotient will be negative. And another case will be a negative number divided by a positive number, it will also be negative. Okay, these facts, as we know, can be extended if you work with 3 factors, 4 factors, and so on and so forth. You just count the number of negative signs. Okay, so without further ado, so now we're ready. For this first one, we have factored, right? So you can see in all these principles, right? They're all involve factoring, right? Multiply C, right? Multiply C cases and multiply, all these multiplication, division, they're all involving factors. So that's why factoring is so important. So for those of you who are in calculus class, you can see that factoring is omnipresent, right? It's everywhere. Needed. Okay, so here we are going to factor. We're going to factor. Okay, but before I factor, remember, I want to get rid of the 6. You can keep it, but I'm going to get rid of the 6. So I'm going to divide both sides by 6. Or you can say 6 times 6 is a positive number, multiply another quantity greater than 0. So the other quantity must be positive. Okay, so you don't have to visibly divide by 6. If you want to, you can do that, but that's what it is. So the narrative is that a positive number multiply another quantity. Let me write this down, right? I write this down. The narrative on this step is if a positive number 6 multiply a bologna is a positive, right? Then I'm certain bologna must be positive. Okay? If 6 times a number is positive, then bologna is positive. So this bologna, of course, is a parentheses, right? So you can use this to just simplify your work. Simplify your work. Okay, next step, factoring. Okay? X minus 1 times x minus 4. Okay, you make sure you got the right factors. We get this product, right? So what situation do we get here? We get in the situation that it's one number multiply another number is greater than 0, right? One number multiply another number. So if you look at the mathematical principle, number 6, it could be either one of these cases. Okay, we have talked about that. There are about 5 methods to solve this inequality. There are about 5 methods to solve this inequality. So I'm going to talk about this method. I'm going to talk about 2 of those 2 methods. In the textbook, there's a table method, but the table method is just directly derived from one of the methods I'm about to talk about. Okay? All right. So to find the solution, what do we do? The first method, method 1, I'm going to see, for both factors, right? We have factor x minus 1. We have factor x minus 4, right? Both are in the domain of these 2 quantities. The domain of the entire thing is all real numbers, right? So just be aware the domain is all real numbers. And we do all of these in the domain. We do all of these in the domain. So we're going to see the sign of the first factor, on the entire number line. I got my number, sorry, I need to use a black. I got my number line, right? And where does x minus 1 change sign? Well, x minus 1 is 0 when x equals to 1. Okay, so when x equals to 1, so 1 is the value. When 1 is plugged in, x minus 1, we got a 0. We got 0. Okay, so that's how you read this chart. Okay, so the number line is scattered with the value of x. So when x is equals to 1, you plug in x minus 1, we got 0. If I select any number less than 1, say I select 0, right? I suppose I select 0 or -2, -5, and I plug in x minus 1, I will get negative sign. I will get negative. Agree? Okay. If I select any number larger than 1, okay, say I select 5, plug in 5 minus 1 is positive. So for all the other numbers, I get positive. And this pattern is correct, okay? So you can test it, all right? So I will do the same for x minus 4, okay? Of course, for x minus 4 is 0 at 4. So I'm going to relatively put number 4 over here. That's my number 4. When x equals to 4, x minus 4 is 0. No problem, right? No problem. Now, for any number less than 4, you pick a number, any number less than 4. So you pick 0. You plug in 0 minus 4 is negative, and you take another number less than 4, you plug in. So you're going to get all negative for any number less than 4. Okay? And for all the number larger than 4, once again, say I plug in 7. If I pick a 7, I plug in 7, and in 7 minus 4, I will get a positive. Okay, so these are the sign distribution of the factor number, one of the factors. So then I'm going to put them together. The sign of the product, right? So we get to use the mathematical principle we just talked about, right? Which is we get to use the mathematical principle we talk about over here. Okay, so I'm going to copy that and put it underneath it so we can use it as a reference. So number line, this is number line. And we have just worked with number 1, right? So I try to line them up. So this is 1, and this is 4. Okay, this is 1, and that's 4. When I choose number less than 1, okay, when I choose a number less than 1, then any number less than 1 will make x minus 1 negative, and we may also make x minus 4 negative. So negative times negative is positive. Negative times negative is positive. So here, I'm going to get a bunch of positive up to 1. At 0, it's a 0, right? If I plug in 0 to this product, if I plug in 1, that's going to be 0. 0 times anything is 0. Okay? So that's 0. Now, I'm going to choose a number between 1 and 3. If I choose a number between 1 and 3, between 1 and 4, I'm going to choose a number between 1 and 4. Between 1 and 4, x minus 1 is positive. Between 1 and 4, x minus 4 is negative. So positive times negative is negative. So here in this part is going to be negative. Okay? So if I choose 4 plugged in here, 4 minus 4 is 0. 0 times anything is 0. So this piece is going to be 0. So when x equals to 4, x minus 1, x minus 4 is going to be 0. If I choose any number, so by this time, I hope you understand the pattern. So when I pick a number larger than 4, when I pick a number larger than 4, x minus 4 is positive, and x minus 1 will also be positive. So we encounter positive time positive. So positive time positive, that's a positive. In the future, if I make such table, then those will be the interpretation. Of course, I will repeat this over and over. So now let's go back to see the inequality. The inequality is asking us, right? So the solution to this inequality would be, because we want the product to be positive, where do we find the input? We find the input here, right? Because in those cases, the product is positive, and we also find input here. That is, the solution to that would be x less than 4, less than 1, or x is greater than 4. So that would be the answer. Interval-wise, some of you like the interval notation. That would be negative infinity, 2, 0, 2, 1, union. Okay, we got a union symbol here, and we got 4 to positive infinity. 4 to positive infinity. So that's it, we're done. We can see in the whole process, solving inequality is really about working out the sign, okay? So versus solving equation, and the rules are different. Okay? So that's the first method. That's our first method. The second method, okay? The second method, so method number 2. Second method, if you're familiar with the quadratic, right? So I used the interpretation of function earlier on to explain this to you. The intention is for you to see that, okay? When we solve this inequality, right? So I'm going to copy and paste these 2 steps. I'm just going to copy the whole thing then. Okay, I'm just going to copy the whole thing. So after we get here, right, we're going to see this piece as a function g. We're going to see this as a function g. Okay, this is our function g. This is our function g, right? Our function g is a quadratic function. It's a parabola. So I'm going to set this piece equals to 0. So I will find x-intercept. Okay, so by setting that, I will find x-intercept. Okay, x-intercepts. We got 2. Okay, because when we set that equals to 0, we get x-intercepts, and these x-intercepts are 1, 0, and 4, 0. 4, 0. And what does that mean, right? Suppose you're pretty good with quadratic, you just graphed it. Okay, you can graph it by hand, you can sketch it by hand. I'm making some adjustment. So this is my parabola. Okay, I'm making some, let's see, say -5. This makes to be 8. That's my parabola. Okay. It doesn't have to be precise. So we say these 2 points are x-intercept, meaning that those are the 2 points. Where the curve crosses the x-axis. The curve crosses the x-axis. Boom. So these are the 2 points 1, 0, okay, 1, 0. So let me draw some arrows here so you can understand what I'm saying. So this is the point 1, 0, and that's the point 4, 0, x-intercept. Okay? All right? So got that and clean it up. So now our question to solve the inequality, and we want G to be positive. Where is G positive? Where is G positive? G is positive when? For all of these inputs, right? So for all of these inputs, G is positive because the entire curve is positive. For all of these inputs, G is also positive. Not including the dots, okay? So give me a second. I'm going to have to change the dot to circle. Okay, I'm going to have to change the dot to circle. So now it's perfect. For all of these inputs, which is less than 1 or greater than 4, the curve is above. That means the function is positive, and we want it positive. But then you say, how about the other part? Well, the other part is negative, right? So if a question is asking for when the function is less than 0, if greater than turn into less than, then the solution will be between 1 and 4. Okay, so that's how, if you use a quadratic and you are familiar with quadratic, and you can do this very quickly. So these are the two major methods I am talking about, and there are other methods, and we just don't have time to go over them. Otherwise, we can only do one question. Okay, so that was done. And let's move on. Let's select another question. Okay. So number 2 is similar. Number three, the only difference is number 3 has a higher degree. But so it's not a quadratic, but you can see how we handle this. Okay, so let's quickly go over number 3. So number 3 is going to be 24x squared. Okay, so let me make sure. I'm going to remove this. Hold on. Sorry. So when working with two softwares, is sometimes the two software don't talk to each other. Okay, so we got 24x to the power 3 minus 48x squared. There we go. And we want it to be positive. Okay. And first thing, of course, you're going to factor. Okay, what I'm going to factor it out? I'm going to factor it out 24x squared. Okay, and inside the parentheses, I would just have x minus 2 greater than 0. And by the time you get to this point, actually, this question becomes easier than the previous one. So let me show you how. For all the real numbers, right? For all the real numbers, x squared is going to be greater than or equal to 0, right? So x minus 4 has to be positive. So from this step, you can simplify the inequality into x squared greater than 0, right? X squared is always greater than or equal to 0, right? So we want it, so this is always greater than or equal to 0. So when you look at the sign of x squared, right? What do you get? You got your number line, right? And 0 is the place, right, where x squared is equal to 0. If you choose any negative numbers, x squared would be what? It will be positive. Only at 0, only at when x is 0 is 0. X squared is 0. You plug in 0 into x squared is 0. If you pick up any positive number, you do x squared is a positive. So that's the sign distribution. Okay? So how about the sign of x minus 2? X minus 2. So you'll be working this, all right? When x equals to 2, x minus 2 is 0. So for x less than 2, you pick a number smaller than 2. Say you pick 1. 1 minus 2 is negative, right? So you're going to get a bunch of negative. And add 2 is 0. Right? You plug in 2 in x minus 2, you get 0. And then for larger than 2, we get a bunch of positive. So we want the product to be positive. So where do we get those products positive? Right? So you do the number line again. And you got 0 here. And you got 2 here. Okay? You got 2 here. For any number less than 0, we got negative times positive. Negative times positive, that's going to be negative. Oops. Okay? So you're going to get a bunch of negative for less than 0. At 0, of course, is 0. Between 0 and 2 is still positive times negative, right? So it's still negative. At 2 is 0. At 2 is 0. And bigger than 2, that's all positive. So our solution for making this piece positive, right? The sign of x squared times x minus 2 to be positive. For that solution, we want positive, right? So the solution would be, the solution to this piece greater than 0 would be just x greater than 2. Okay, so can you graph? Of course you can graph, but you're not graphing a quadratic, you're graphing a straight line. Okay, you're graphing a straight line. So that you can graph, so that would not be necessary. That would not be necessary. Okay, so now we've done number 1, we've done number 3, number 2 is similar. So let's look at some more challenging questions here. Okay, let's take a look at number 4. Let's take a look at number 4. Number 4 has its inherited complexity because number 1 is a cubic root, right? So we got 2/3 multiply x raised to the power of negative 1/3 multiply x minus 3 minus x raised to the power of 2/3, right? So how do we solve this inequality? Okay. If you write it out, so some people, okay, so let me point out some mistakes that people tend to make. Okay, let me point out some mistakes people tend to make. To solve this inequality, some people will do, okay, so we just adding x to the power 2/3 on both sides. So we have greater than, so this will become greater, right? So we add x raised to the power 2/3 on both sides. So we got this inequality. And some people will say, oh, I know this. This is just 1 over x raised to the power of positive 1/3. And that's a cubic root of x, right? You're right. So you are right. And they see denominator, and they're in, so one scenario. Did I say that? Did I pronounce that word correctly? I don't know. Just correct me afterwards. Okay, because I'm not gonna look up the dictionary. All right. So when we see denominator, some people's instinct is to multiply this on both sides. Okay. So the next step, this person will multiply the denominator on both sides. Okay. And of course, this piece, you can also change this piece, by the way, because let's make it consistent, right? X squared. So this piece is moved down here. And then, it's great because now you see cubic root of x raised to the power 3. And that equals to x, right? It's seemingly that, so now you get to the next step. So this is reduced, and you end up with this. It seems to be much simpler. However, I need to tell you, you cannot do this. You cannot do this. Why? Right? Why you cannot multiply both sides by cubic root? Why we cannot multiply by cubic root? Like what we would have done if A equals to B, then AC equals to BC. Okay? But the whole thing is a mistake. The whole thing is a mistake. So I need to point it out. So this step, okay, I'm going to be specific. This step is okay. Okay, this step is okay. But this step, okay, this step, and what is not okay? So let me be specific, okay? So move this, okay, so multiplying both sides by cubic root of x, that step is wrong. Okay, that step is wrong. So this step is the wrong step. Okay, so let's be specific. This is the wrong step. Oh, look, the two software don't talk to each other. Okay, so let me move it over. So this is the wrong step. Why is it the wrong step? So you get in here, you think your life is easier? No, you're not getting the right answer. You're not going to get the right answer. Why this step is the wrong step? The reason it is a wrong step because we do not know the sign of x raised to the power 3x. So let me remove this. The reason that this step is wrong is that we don't know the sign of cubic root of x raised to the power 3. Okay? The function has a domain of all real numbers but 0. Okay? The domain is all real numbers but 0. Right? So x can be positive or negative. So remember the principle we talked about earlier, right? The principle we talked about earlier, right? All of these, I'm going to copy and paste and bring it here. Okay? All of these. We can do that, yes, but we don't have equal. It's wrong to do that. Okay? It's wrong to do that because we do not know the sign of C. And the C is the cubic root of x raised to cubic root of x. This kind of mistake is all-time common mistake. This is all-time common mistake. So only if when we are certain either C is positive, then we keep the inequality sign, or C is negative, and then we switch the inequality sign. If we're not certain, we cannot do this. Okay, so that's clear. I hope that's clear for you. Okay, I hope that's clear for you. Otherwise, ask me in person. All right, so we cannot do that. Okay, now let's move forward. What can be done? Okay, so what can be done? So let me clean this up. Okay, and we need to understand all these reasons. Okay, so we're going to put this beneath us. So what can be done? What can be done is that we should factor the left-hand side. What the right thing can be done, okay? So to factor this, we are going to, of course, you guys know the rule of thumb. The rule of thumb is to factor out the part with the lowest exponent. And we got a denominator here, right? So I'm going to just set it up. We got this. Our intention is to factor out the 3 and factor out x raised to the power 1/3. So we want to factor out this piece. Okay, so we want to factor out this piece. And we already, we have what we're going to take out the 1/3. And this piece, we don't have x raised to the power negative 1/3. So we're gonna do the thing that you guys hopefully you are familiar with, is that we're gonna multiply by 1, right? We're gonna multiply by 1, and 1 turn into, we're gonna multiply by 1, and 1 turn into x raised to the power 0, right? And x raised to the power 0, 0 is turning into negative 1/3. Oops, sorry. Turning into negative 1/3 plus 1/3, right? So negative 1/3 plus 1/3, that's 0. So that's still, so 0 is turning into that. And so further we split, we turn that into x raised to the power of positive 1/3. So this whole piece is really just 1, okay? So this way we can remove the positive sign here. So this way we can factor out the 1 x to the power negative 1/3. But we also need to take out the 3 in the denominator, right? So we're going to write it as 1/3. 1/3 times 3, that's going to be. So these are the things you probably do it in a scratch paper because you never see this kind of work in any textbook. So after you set up like this, now we can safely take out x to the power negative 1/3 divided by 3, right? So we take out this piece. What do we have left, right? So we have left with 2. So 2 times x minus 3, that will come along. Minus the second part, we have 3. Oops. The second part, we have a 3 here, right? So this piece, 1/3, and this piece is out. So we just have x to raise the power 2/3 multiply x raised to the power 1/3. Okay? Greater than 0. And x raised to the power 2/3 multiply x to the raised to the power 1/3, we have the same base. We just add up the exponent. So this piece is gone. 2/3 plus 1/3, that's 3/3. Right? 3/3. 3/3 is 1. If it's 1, then we can omit it. So we come to this point. You can go from this step directly here. However you mess with this step, I really don't mind. But if you show it, I will have to check. Okay? So now we have factored out this piece and we got a bracket. So we're going to simplify the bracket. Okay, so let's see what we have in the bracket. In the bracket is 2x minus 6. 2x minus 6, right? So 2x minus 6 minus 3x, we turn into what? Negative 6 minus x. Minus 6 minus x. So here, if you like, you can factor out the negative sign if you want. It's not entirely necessary, but you want to, you can. We bring out the negative sign, so we get a 6 plus x. So that's considered factored. And how do we go from here? To go from here, there are a number of ways you can do it. But first thing first, you want to simplify. Okay, so this time, I'm going to have the bracket on the top, remove the bracket, x raised to the power negative 1/3. I know that's just a cubic root, so I'm going to write it in my familiar situation. And then I kind of want to get rid of the negative 3. I want to get the negative 1/3, sorry, negative 1/3. How do I do that? I'm going to multiply both sides by negative 3. If I multiply both sides by negative 3, I will have to change the direction of the inequality sign. And I will get this, that will become less than 0. Because 0 times 3 is 0. Okay, 0 times 3 is 0. Now, from this step to the next step is because I multiply both sides by negative 3 and I applied this mathematical principle. So I'm going to put it here. Okay, multiply both sides by negative number. Okay. Well, I need to mention there's a common mistake here. I need to mention this. Some people, while doing this, they will show work like this. They will multiply by a negative 3. They multiply by negative 3, right? Like this. And they switch the direction of inequality sign on the next step. This will constitute a mistake. Why is it a mistake? Because, okay, before this step, right, so let me reserve that step, right? So before I multiply by negative 3, this is how it looks. Then you multiply by negative 3, you did not switch. You must switch here. So when you multiply by negative 3, if you do this explicitly, you must switch here. If you don't switch, I would see that as a mistake. Okay, minus 2. So if you choose to show work like this, please switch right there because it's happening at the same time you're multiplying by negative 3. Okay, so for those of you who tend to make this kind of mistake, you can just omit this step altogether. You don't have to show that step. If you show that step, show it right. Okay? I'm going to leave that step over there. It's not I have to see that step. But I know many of you out there, you tend to make that mistake. What a mistake? Let me say it again. You have greater than there, and then the next step you switched, and this step is already you have already made a mistake. Okay, and the cause of that mistake is -2. Why is -2? Because from this step does not take you to the next step. And from this step, it does not take you to the next step. So by not making that switch, you make these all three statements wrong. That's why we -2. Okay. So, but anyway, so let me just leave it there. I'm going to show the right step. So if you choose to show your work, this is how you should show your work. So now we're solving an inequality. And you know that we cannot multiply both sides by cubic root of x. What can we do? We work with the sign. Okay, so we work with the sign. The sign of the denominator, cubic root of x, right? Which is, our number line 0. This is our 0. And when we choose x equals negative, in cubic root would be negative, right? At 0 is 0. But cubic root is in the denominator, so we should never divide by 0, right? Okay, so when x is positive, cubic root of x is positive. And then we look at the sign of 6 plus x, or x plus 6. Okay, they're the same thing. They're x plus 6, doesn't matter. So this quantity, we have our number line. When x equals to -6, right? 6 plus x is 0, right? 6 plus x is 0. For x less than -6, you say you pick a -7, that's going to be negative. Oops, negative, right? Negative. Oops. Okay. Sorry. Let me change the mode. If you pick a number larger than -6, if you pick a number larger than -6, say -5, you plug in, you get a positive. 7, you get positive. So you get positive on this side. Okay. So in the end, we want the whole thing to be negative. So the sign of this piece, okay, on the number line, we got a -6. And we got a 0 here. We have them line up. Okay. I do this lining up thing because these pieces, I want to line up. So this way you can see the lining of -6 and the lining of 0. They're not perfectly lined, but it just make it easier for us to observe. Okay. But anyway, so let's move forward. So when I pick a number less than -6, right? We got negative times negative. Negative times negative is what? Positive. At -6 is 0. Between -6 and 0, between -6 and 0, that's a negative times positive. That's negative. At 0 is undefined. At 0 is undefined, okay? Because dividing this, so if you like, you can put, just leave it empty. If you really want to put something there, I would put infinity there. Okay? And were not applied, right? And for larger than 0 is a positive time positive. Positive. So the solution, what will be the solution? The solution to that inequality, the solution to this inequality would be between -6 and 0. So that solution would be -6 less than x less than 0. So that would be the solution. And if you want an interval notation, that would be -6, 0. Okay, that's the interval notation. That's the interval notation. Okay, so you can see there's so much involved when solving inequalities, and they're rather complex. They're rather complex. Now let's go back to see that if you went with the wrong way, if you went with the wrong way, what would you get, right? So say we come back here. If you're gone with the wrong way, what would you get? Okay, let's see what are you gonna get. Okay, from this wrong step. Okay, you should have a good laugh. Okay, so we know this is x, right? And this piece and that piece is reduced. So we ended up with 2/3 minus x, 2/3 times x minus 3. You can multiply both sides by 3, right? So from here, some people probably happily doing this, not knowing, right? So this is 3. And then you open up the parentheses, you get to the next step, you get 2x minus 6 greater than 3x, right? Greater than 3x. And then subtract 3x on both sides. Subtract 3x on both sides. We just get x less than, right? Less than -6. So had you gone with the wrong step, you're getting x less than -6 as a solution. Compare these two solutions, right? Compare these two solutions. Your solution, well, that student is going to lose a lot of points. So this solution, which is x less than -6, compare with our right answer, you can see they're very different, aren't they? So you're completely on the wrong track. Now, how do we know if we are right? Okay, and of course, in this case, you can graph the function entirely. So here I'm giving you a tool. When you work with the equation like this, right? How do you know you get the right answer or not? Provided that when you're working on your homework, right? And we want this to be positive. This software I'm using doesn't always graph well. But suppose that I'm going to graph this function, right? I want to just verify if my answer is right. So I'm going to try this software, and we also have decimals, right? So we have cubic root of x, okay? And this will be, of course, is the cubic root of x squared, right? I'm going to graph this function. I call this function g. I'm going to graph it. That's the curve. It's a pretty, so let me make some adjustment. Okay. You see 0 is not in the domain. Okay, so I got -3, +3, just to make some, here is a -5, +5. Okay. It's not a very good picture. It's not a very good picture. So, hold on. We are going to make it say -10, +10. Okay, so it looks like there are pointed place. It cannot be 0. We know that it cannot be 0. Let me make it say -20, +20 to see if we can smooth out the curve, right? And we want this curve to be positive. Okay, we want this to be positive. All right. So you can see all of these, the curve is beneath x-axis. And our solution is between 0 to -6, right? We want to verify that. So I'm going to move over, right, to say -8. -8. You can see at a -6, at a -6, at a -6, the curve goes below. The curve goes below. Okay. To see a better picture, I actually usually cross-reference with decimals. Okay, so let's take a look at decimals. Okay, so let's take a look at decimals, and I got decimals here. Let me make sure I share decimals. Okay, share decimals. Okay, the software I was using there is really good for typesetting, but it's not super good for graphing. Okay, so I'm going to graph with decimal. Let me write down the question. The question, which is 2/3, right? 2/3. Okay, I'm going back to decimals. So we got 2/3. Okay, x raised to the power of -1/3 minus x raised to the power of 2/3, right? So decimals, wait, did I do it right? Did I copy the question function right? 2/3, oh, I missed the x minus 3, sorry. I missed x minus 3, no wonder. Okay, there we go. So we got a better picture, right? We got a better picture. So you can see that from this picture, right? So let me zoom in a little bit. You see the point where it crosses, right? So if it's a -6, 0, that's where the curve crosses x-axis. From -6 to 0, the curve is above. It cannot be 0. So the decimal graph is also not perfect because it cannot be 0. So we still need the mathematics to guide our understanding of the graph. The entire piece, right? The other piece for x greater than 0, the entire piece is negative, right? So all this piece is negative. And only this piece is only this piece between 0 and between -6 and 0. This is the only piece that's positive. So our answer is right. Our answer is right. That's what I'm saying. Okay, so I'm going to take a screenshot of this. Okay, I'm going to take a screenshot of this. So you decide, right? So we got to decide that what will be the right answer, right? So this curve, So this piece of graph, do you guys see that? Let me see. Stop share, share again. Okay. So now you can see from this picture much more clearly, right? We got the right answer. We got the right answer. So how do you cross-reference? That's how you cross-reference to verify. Because after all, you know, even though you cannot use calculator for my quizzes, for my, you know, for my dinky requirement, but you can, when you're doing your homework, you can check it. So you understand those steps. All the steps we did is correct. And if you took the wrong step, you get the wrong answer, x less than -6. X less than -6, that answer means that all the number less than -6 will be solution. That's obviously wrong, right? They're actually negative. They're actually negative. We want the whole thing positive. Our solution is between -6 and 0, exclusive. I wish to conclude this part of the lesson because it's over an hour already. Okay, so I will plan to make another one, but not maybe not this day. I need to go to work pretty soon. And thank you for watching.